Welcome to episode number 204 of CXOTalk. I'm Michael Krigsman, and CXOTalk brings the most innovative, interesting, really great people for a live, spontaneous video conversation. And what an incredible way for me and for all of us to interact with the guests. And you can follow us on @CXOTalk and use the hashtag CXOTalk to ask questions and to make comments directly to the guest. So today on episode number 104, I'm speaking with Anthony Scriffignano, who is the chief data scientist at Dun Bradstreet. This is his second time on CXOTalk. He is such an articulate and clear communicator, and we're going to talk about the foundations of artificial intelligence and the implications for business in a very practical way. Anthony Scriffignano, how are you today?
Michael, thank you very much. It's great to be with you again.
Well, it's awesome that you're here. So please share with us your background and tell us about Dun & Bradstreet.
Sure. So Dun & Bradstreet, first of all, is the world's arguably the largest commercial data environment that you can encounter for information about businesses globally. And we maintain a database over 250, closing in on 260 million entities right now. We never forget a business, even after it's out of business. This information is collected from hundreds of countries all over the world. It's collected in different languages and different writing systems. It's updated millions of times a day. So it's a pretty big environment, very, very dynamic, lots and lots of change in that environment. Those countries have different laws. We have to be very careful about how we curate the data, what we discover, permissible use, the whole nine yards. And we certainly have to worry about implications of things like changing environments and changing behaviors. Some of the things that we'll get into today that touch on the space of AI and machine learning and some of the underlying things. As far as my role as chief data scientist, one of the mandates that I have is sort of looking over the horizon, looking at technologies and capabilities that will enable us going out into the future. So not 2 days from now, but before they become problematic, we have to be able to be very much aware, very well informed. So I spend a lot of time in the data science community of practice working with some of the top data scientists in the world to basically say what we think out loud and be cold crazy if we are, and to share ideas and thoughts and to understand some of the new capabilities that are becoming possible, and then making sure that we understand how those apply to this environment that we maintain.
So we're going to be talking about artificial intelligence and machine learning and autonomous systems. But before we do that, just briefly share with us the kinds of things that you're using AI or machine learning for inside Dun & Bradstreet.
Sure. So we're looking at a number of different processes that touch on this space. The most obvious one is in computational linguistics, natural language processing, things of that nature. We need to be able to look at large amounts of data. Some of it is unstructured. Actually, a lot of it is unstructured. And we need to be able to understand things that are very difficult to understand because they're proper nouns, right? So you can look up the words in the dictionary, but you can't look up your name in the dictionary. And by the time you can, it's old news. So we have to be able to deal with discussion about places, discussion about people. So that's a very big part of what we do. Another thing that we do is something called recursive discovery, which is the ability to essentially adjudicate the truth. You have to be very careful with information that you pull in, even information that you know to be true, because not all true information is true at the same time. And truth is somewhat fungible. It's not really a black and white kind of thing in many cases. And then the big Megillah, if you will, is malfeasant behavior. We call it that. Fraud is another word for it, but sometimes when people commit actions to us, they haven't actually committed fraud yet because they haven't gained financially. So watching people behave in bad ways, certainly something where these types of techniques are very much a part of what we think about in terms of how can we inform our thinking and how can we sort of do what we're trying to do to inform our customers.
Okay, so these are areas that you're focused on inside D&B. But now let's take a step back. And so when you as a data scientist think about the term AI, what do you think of? What does it actually mean? And let's try to go beyond the hype, because AI has become the latest jargon. You know, it's even better now. It's exploding faster than digital transformation, which
Sure.
has exploded into meaninglessness. So what
Yeah.
do you? Yeah.
If there's nothing else that our industry is good for, it's for creating terms that people can use that have ambiguous meaning and can be taken to mean almost anything in any situation. And this is certainly one of them. So it's one of those things that you understand, but then when you try to define it, scholars will disagree on the exact definition. But artificial intelligence collectively is a bunch of technologies that we run into. So you'll hear AI, you'll hear machine learning, you'll hear deep learning, sometimes deep belief. Neuromorphic computing is something that you might run into, or neural networks, natural language processing, inference algorithms, recommendation engines. All of these fall into that category. And some of the things that you might touch upon are autonomous systems, bots. Sometimes we will hear talk of, well, Siri is probably the most obvious example that anybody runs into, or any of the other. I won't try to name them all because I'll forget one. But things of that nature, where you have these assistants that try to sort of mimic the behavior of a person. When you're on a website and it says, click here to talk to Shelly, or click here to talk to Doug, you know, you're not really talking to a person, you're talking to a bot. And so those are examples of this. Generally speaking, that's the broad brush. And then if you think about it as a computer scientist, you would say that these are systems, processes that are designed to do any one of several things. One of them is to mimic human behavior. Another one is to mimic human thought process. Another is to behave intelligently, and I'll put that in quotes. Another is to behave rationally, and that's the subject of a huge debate. Another one is to behave ethically. That's an even bigger debate. So those are some of the categories that these systems and processes fall into. And then there's ways to categorize the actual algorithm. So there are deterministic approaches, there are non-deterministic approaches, there are rules-based approaches. So there's different ways you can look at this. You can look at it from the bottom up, the way it just ended, or you can look at it in terms of what you see and touch and experience.
So, from a business perspective, when we hear terms like machine learning, AI, cognitive computing, is there some type of framework in which we can think of these things? How do they relate to one another? Are they synonymous?
They're not synonymous. So cognitive computing is very different than machine learning, and I would call both of them a type of AI, just to try and describe those three. So I would say artificial intelligence is all of that stuff I just described. It's a collection of things designed to either mimic behavior, mimic thinking, behave intelligently, behave rationally, behave ethically. Those are sort of the systems and processes that are in the collection of soup that we call artificial intelligence. Cognitive computing is primarily an IBM term. It's a phenomenal approach to curate a massive amount of information that can be ingested into what's called a cognitive stack, and then to basically be able to create connections among all of the ingested material so that a particular problem can be sort of discovered by the user, or a particular question can be explored that hasn't been anticipated. Machine learning is almost the opposite of that, where you have a goal function. You have something very specific that you're trying to find in the data, and the machine learning will look at lots of disparate data and try to create proximity to this goal function. Basically try to find what you told it to look for. Typically you do that by either training the system or by watching it behave and sort of turning knobs and buttons. So there's unsupervised and supervised learning, and that's very, very different than cognitive computing.
And what about autonomous systems? We're kind of like
Okay,
this is truly
this is good.
this is an alphabet
Yeah.
soup. Okay.
So we got to get all the colors in the palette here to be able to speak this language. So autonomous systems are systems that behave without human interaction, essentially. They go off on their own and do what they've been told to do. And you can think of a drone that's not being flown by somebody as an example of an autonomous system. Lately, there's been a lot of talk about autonomous vehicles, which is sort of an interesting kind of oxymoron, because they're not really autonomous. There's somebody in the car, but that person in the car isn't driving the car. And that would be an example of that. And then there are sort of semi-supervised, somewhere in between autonomous and not autonomous, for lack of a better word that means that. You might have systems where you can intervene if necessary. So think of like the autopilot on an airplane. They like to call it the flight control system, or flight. There's other words for it in airplanes. They're basically designed to help the airplane maintain a course, maintain an altitude, maybe do something like change altitude or change direction with some input. But at certain points, if there's a lot of turbulence or something unusual happens, the plane's in an unusual attitude, the thing breaks, the autopilot system or the autoflight system basically turns off and says, it's your airplane, have a nice day. So they're not completely autonomous. There's if all else fails, give it to the human kind of function in many of these.
Well, certainly we should talk at some point during this conversation about human functions that are augmented by AI. But there's a few things we need to get to first. And we have a question from Twitter. It's a really good question. Let me tell you what it is, but let's again address it a little bit later. And this is from Arsalan Khan, who's asking, when an AI system makes a decision that is based on bad data or bad algorithms in business, who is responsible for that? But which is a fundamentally important question. But let's come back to that, because there's still some basics I think we need to get out of the way, and we'll definitely want to talk about the ethical aspects.
Yeah, we're going to have to parse that one too, because we're going to have to define bad. But I'll let us get there.
Yeah, we'll get there in a couple of minutes. Okay, so autonomous systems, machine learning. What does all of this, first off, have to do with AI?
Well, basically, we need AI for autonomous systems to behave autonomously. That would be the simple way to put it. For an autonomous system to work properly, you could imagine you had a train, and you wanted the train to be able to come up to speed, travel down the tracks, slow down when necessary, don't go through any signals, and stop at the next stop. I'm not a train engineer, but I'm guessing that I could probably build an analog system to do most of that. And I probably would still want somebody sitting there with their hand on the brake just in case it doesn't work. But I think I could probably build a system that did not require a lot of intelligence to do that. But now you think about what happens when there's no railroad tracks, when the road might have lines in it that might get fuzzy or might be covered with rain, or a kid runs out with a ball, or there's a police car and you need to pull over, or a plane lands in front of you, or an elephant walks out in the road. And pretty soon you get into this system where the number of things that can happen starts to overwhelm sort of discrete description and a basic set of rules. Now we start to need AI to be able to deal with a problem like that, to be able to effectively learn. And I have to say, we tend to anthropomorphize these systems and these algorithms. We talk about machine learning and we talk about systems learning. They're not learning. They're ingesting information and they're organizing it in ways that they've been designed to organize it. I actually use the term symbiotic intelligence instead of artificial intelligence. These are systems that have been taught to learn in ways that we've described for them, with primary goals that we've given to them. But without having to say all that, we can say learning.
Okay, so again, in our quest to demystify the basics, you explained that the systems, quote unquote, learn. And we hear the term modeling, right? We hear the term we have to train. When you talk to data scientists and they're talking about machine learning, they say we have to train the model, create the model and train it. What does that mean?
So, I'm not sure if we're demystifying or mystifying this, because unfortunately, this is a field where every time you talk about something, there's new terms that come in. So let's just talk about what a model is mathematically first, and then we'll talk about how it applies to machine learning and training the model. So a model is basically a method of looking at a set of data in the past, or a set of data that's already been collected, and describing it in a mathematical way. And we have techniques based on regression where we continue to refine that model until it behaves within a certain performance. It basically predicts the outcome that we intended to predict in retrospect. And then, assuming that we can extrapolate from the frame we're in to the future, which is a big assumption, we can use that model to try to predict what happens going forward mathematically. The most obvious example of this that we have right now is the elections, right? So we look at the polling data, we look at the phase of the moon, we look at the shoe sizes, whatever we decide to look at, and we say, this is what's going to happen. And then something happens that maybe the model didn't predict. And I saw some great articles over the last few days blaming the data, stupid data, right? The data doesn't have stupidity. And I'm not saying the people that interpret the data are stupid either. I'm saying that things can always happen within random variation, or they can always happen according to attributes that weren't anticipated. So modeling is a good thing. It's an important thing. We all live and die by certain models in our lives. That's how interest rates happen. That's how that's how the certain warnings come up in your car. There's all kinds of reasons why we want models to work, but we also have to be very humble that the human brain doesn't work that way. It doesn't work that way at all. So now we get into AI, and the way some systems work, not all, is they say, show me something that looks like what you were looking for, and then I'll go find lots of other things that look just like it. So train me. Give me a web page and tell me on that web page which things you find to be interesting. And I'll go find a whole bunch of other web pages that look like that. Give me a set of signals that you consider to be danger. And then when I see those signals, I'll tell you that something dangerous is happening. That's what we call training.
Okay,
And
Anthony, I don't mean to interrupt, but please drill down a little bit more on this. So we hear, for example, companies coming up with image search. So
yes,
train us in terms of images, mountains or
sure.
seashores. What does that mean? How does when you say find something interesting on the page? Can you drill into that?
Sure. So imagine that I gave a whole bunch of people, and the gold standard here is they have to be similarly incented and similarly instructed. So I can't get like, 5 computer scientists and 4 interns, and you try to get people that more or less have either they're completely randomly dispersed or they're all kind of trying to do the same thing. There's 2 different ways to do it, right? And you show them lots and lots of pictures, and you show them pictures of mountains mixed in with pictures of camels and pictures of, maybe things that are almost mountains like ice cream cones, and you let them tell you which ones are mountains. And then the machine is watching and learning from people's behavior when they pick out mountains to pick out mountains like people do. That's called a heuristic approach. When we look at people and we model their behavior by watching it and then doing the same thing they did. And that's a type of learning. That heuristic modeling is one of the ways that machine learning can work, not the only way. There's a lot of easy ways to trick this. So people's faces are a great example. When you look at people's faces, and we probably all know that there are techniques for modeling with certain points on a face, the corners of the eyes. I don't want to get into any IP here, but there's certain places where you build angles between these certain places, and then those angles don't typically change much. And then you see mugshots with people with their eyes wide open or with crazy expressions in their mouth. And those are people trying to confound those algorithms by distorting their face. It's why you're not supposed to smile in your passport picture. But machine learning has gotten much better than that now. We have things like the eigenface and other techniques for modeling the rotation and distortion of the face and determining that it's still the same thing. So these things get better and better and better over time. And sometimes as people try to confound the training, we learn from that behavior as well. So this thing all feeds into itself, and these things get better and better and better. And eventually they approach the goal, if you will, of yes, it only finds mountains, it never misses a mountain, and it never gets confused by an ice cream cone.
And how is this different from traditional programming, right? Because with traditional programming, we can put up pictures. You can do a Google search, or a few years ago, maybe before there was big machine learning, and pick out pictures of mountains or whatever. So how is this different?
So without getting into a whole debate on how it used to work versus now, because I'm sure there's a bunch of people on the internet that will take us to task, because this has been done in a lot of different ways. The original way that this was done was through gamification or just image tagging. So they either had people playing a game, or they had people trying to help and saying, this is a mountain, this is not a mountain, this is Mount Fuji, this is Mount Kilimanjaro, and this is, so they got a bunch of words, they got a bunch of people that used words to describe pictures using their human brain.
Amazon Turk, for
There
example.
you go, Mechanical Turk, right?
Yeah.
And then using those techniques, they just basically curated a bunch of words and said, all right, the word mountain is very often associated with, there's a high correlation statistically between the use of the word mountain and this image. Therefore, when people are looking for a mountain, give them this image. When they're looking for Mount Fuji, give them this image and not this image. And that was basically a trick of using human brains and using words. That's not the only way it works today. There's many more sophisticated ways today.
Okay, this is good.
I have a good example for you. After the earthquake and the tidal wave happened in Japan a number of years back, we needed to try to help the people in Japan. And one of the things we had to do was look at satellite images and find roads and infrastructure that were impacted by all of these horrible things that happened. So we taught a series of algorithms to find previously unbroken straight and curved lines that were now interrupted. And then we had an algorithm that inferred the degree of impact to the infrastructure around a business. So that was learning about something that just happened using data we never used before, that in this case was graphical, that we could reduce to something mathematical and observe it, quote unquote, thousands and thousands and thousands of times very quickly. That's an example of a real impact of something.
And what about autonomous cars? If you live in some place like San Francisco, you see these autonomous cars driving in the streets. What is the role of AI, machine learning, other technologies in making that possible?
So a whole industry in the process of exploding right now, right? So we started out very much like the auto flight systems in airplanes. We wanted the car to stay in the lane and stay at a certain speed and remain a certain distance away from the car in front, right? So if a car pulled in front of you, the car that you're driving in, let's call it auto flight mode or auto drive mode, would slow down enough to keep a certain distance and override the intention to drive at a certain speed, but not change lanes. So there's this, stay in the lane, stay at the speed, unless you're going to hit somebody, basically. Now the autonomous cars are way beyond that, right? So they know something about the road in front of them. They know something, like essentially what a GPS system would know in terms of what are the roads ahead of us, what does the traffic look like, maybe so the overall goal might still be get from point A to point B, stay in the lane, try to drive at this speed, but they're much, much, much more sophisticated in terms of the information that they can bring in and the types of decisioning. So they don't have to just say, well, what do you want to do? They can do it for you to a certain extent. There are still some very real concerns. One of them, we all read the news, right? So, an autonomous car isn't going to speed because there's a speed limit and that's the law. Well, people speed. People drive with traffic, right? And you try going on a highway and driving the speed limit and see what happens. In certain cases, that might be very dangerous. And I'm not suggesting we speed, but I'm just observing as a scientist that people do, right? So, what do you do in a situation where common sense, in quotes, or at least common practice dictates that you do something that's against a rule that's built into a system? What do you do when a kid runs out in front of you with a ball and a dog runs out in front of you chasing the kid, and you got to hit the kid or the dog? And this is horrible, but these things happen, and it's never happened to me. I hope it never does, but I'm pretty sure that I wouldn't just throw my hands up and let the car do whatever it wants. I would have the car do something. Sometimes jamming on the brakes is the most dangerous thing you can do. So, autonomous systems are able to approach the behavior of a safe driver driving in predictable environments right now within reasonable limits, as long as there's a person in the car to take over. Our goal is to get better than that, but think about the number of things you have to believe for that to be, fully functional. I think we still probably want a human being there. I don't think we want the autonomous car going out and delivering pizza all by itself, although probably before I get a chance to eat these words, that'll be happening anyway.
We have another question from Twitter, and this is a well-timed question because we're talking about the applications, the practical applications of AI and techniques like machine learning. And this is from Frank McGee, who's wondering how are companies using AI to predict the behavior of customers and prospects? So of course, this is the sales question.
Yeah, and of course, in my case, we're trying to use it to predict the behavior of the bad guy as well. So it goes either way. Um, so, you know, obviously the $1 billion idea is if I could predict by people's behavior what they're about to do and approach them in their time of need before that need arises, or just as that need arises, then I have more of an opportunity to serve that customer, and maybe I can take some business away from people who aren't so agile and so smart. That's basically the underlying idea. And AI is certainly being used. We've all seen the movie, or many of us have Minority Report, where the guy walks into the shopping mall and all of the digital advertising on the walls is recognizing his eye implant and trying to sell him things and tell him that he needs things. And I think we've all had experience with maybe going on to I don't want to name a site, but something like Amazon, for example, where you might search for something and not buy anything. And then later on you get an email, trying to offer you something. Those are really primitive examples of this kind of technology, but it's getting way, way, way better. So by watching enough people behave in a well understood environment with well understood context, we can start to anticipate clusters of behavior and take action on it. A great example would be if we watch people's behavior in supermarkets. So people go into a supermarket and we can easily put technology on the cart that says, where are they going? How long do they stop? And then ultimately, what did they buy? And by using behavior like that, we can reposition things in the store according to certain goals. Like we'd like to make them walk around more, or we'd like to lead them toward the more expensive items, or whatever it is we want to try to get them to do. So that technology is starting to happen, and it's starting to happen in digital advertising big time. It's starting to happen in very simple things, like when you go to a movie theater, there's a lot of technology watching what people do in environments where we understand the context very well, and our behavior is being manipulated in ways that you'd be amazed at some of the ways that we're being touched that we don't realize. And then there's of course a creepy factor to that too, which we have to be careful about.
We are talking on episode number 204 of CXOTalk with Anthony Scriffignano, who is the chief data scientist at Dun Bradstreet. And you are welcome to tweet questions in using the hashtag CXOTalk. So, Anthony, we've been discussing the technology underpinnings of AI, but AI is unique in the sense that the conversations very quickly turn to questions about the ethics of AI, whether we should be using AI and to what extent and where AI should be prohibited. It extends to questions such as Arsalan Khan raised earlier, such as when something goes wrong with an AI system and the outcome, who's responsible? And so first, what is it about AI that lends itself to these very open-ended philosophical questions? Very different from the cloud in that sense.
Totally different. Yeah, totally different. So we talk about disruptive technology as something that forces you to change your behavior, right? The cloud definitely forced us to rethink security and privacy. A laser pointer doesn't really force me to change my behavior. It's a long stick. I can go point, right? But AI is here to stay. It's not going anywhere. There's every reason to believe that it's the degree to which this type of technology will be pervasive in our daily lives will increase and become more difficult to even notice. So we just have to accept that. Now, what is it about it that puts us in a position to question some of these either moral questions, legal questions, ethical questions? Well, as we give up our autonomy, as we let things do things for us, there are certainly some legal questions about whether those things are essentially electronic agents. If I hire somebody to go deliver dynamite, legally, right? I'm not completely exonerated from some stupid thing that they might do while they're delivering the dynamite, like trip and fall and blow something up, right? So there are legal principles for agency. Those legal principles are probably not completely codified to cover digital agency, just as an example. So if you ask a person to do something for you, there is a very clear understanding in the law of the degree to which your liability extends into that action. The law typically does not catch up with technology. When the law tries to anticipate technology, the purveyors of that technology often change their behavior knowing what the law is. And so you wind up with a law that either sort of loosely covers a set of behavior or covers what that behavior was intended to be, and then it changed. And then on top of that, you have the rate of change of bad guys and how people will misuse technology. So these are really complicated issues. The thing I loved about that question that was asked was if an AI agent, or let's just call it an electronic agent for lack of a better term, does something wrong, are you responsible? Part of the issue here is defining wrong. Someone would say, look, the system drove the autonomous car into a wall because the wall wasn't on the map, and it's not the car's fault, it's the people who built the wall's fault. I don't know about that, because you wouldn't drive your car into a wall, right? If you were there, you wouldn't drive the car into the wall. So I could make an argument that the people who made that system did a bad job of creating an AI agent that mimicked human behavior, because a reasonable human wouldn't do that. And this reasonable person standard is in the law already. Does it apply to digital things? Not so much yet. So I think we have sort of the building blocks there. And I hope that we don't have to completely rethink ethics and moral behavior. But I think we really do have to think about how much of this legally applies. And in certain cases, I'm not a lawyer, but I work with them a lot. You have to see how the courts are going to interpret it, and you have to see what's going to happen in different countries. You have to see how this might change the ability to bring these technologies to the market. We also have to be careful that we don't, because we're so afraid of things like that happening, that we don't put something in like the Watson system right now that's using all of the curated medical literature to help emergency room doctors. I really want them to do that. I really want them to do that well, because I may have to go to an emergency room someday. And if they're too afraid to use technology like that because it might make a mistake and not learn from it, then we don't do anything. And that first step never happens. So we have to, as human beings and rational purveyors of, the advances in technology, I think we have to walk that line carefully and not just be afraid of it.
So we only have about 15 minutes as opposed to 3 or 4 days to continue this discussion. And the issue of data, okay? So we have the separation between, or the AI outcome relies upon the source of data and the quality of data, along with the quality and the caliber of the algorithms and the learning, the machine learning that has taken place. So how do you separate from an ethical perspective, for example, how do you separate out those two in order to answer Arsalan Khan's question in terms of pointing responsibility when you have a negative outcome, or for that matter, if you have a positive outcome?
Yeah, I don't think you do. I think that data is permeating everything, and the fact that you didn't go use the right data to do what you should have done in your algorithm is not an excuse. The fact that you didn't realize that you took data in motion and created data at rest in order to put it in some training environment, and the world changed outside while you were doing your training, well, shame on you. We should know these things. The science of using data hasn't changed because of machine learning. We have to remember that there are certain things that we need to do in order to use data in motion, or data with varying degrees of veracity or velocity, or or value to a particular goal. Those are big data problems that we had. We're not allowed to say big data anymore, but that we haven't completely solved any of those problems yet. So we need to make sure that we make new mistakes. We need to make sure that we keep all of this learning that has brought us to the point where we can create amazing things like this, and really keep in mind the fact that the underlying data can influence the outcome of the behavior of these things, just as well as having a wrong algorithm or giving it the wrong goal or not supervising it and changing it. All of those things are aspects of getting this right. It will not get any easier. It will get more complicated. And I would say, that's the work of the future. Everybody talks about how many jobs will be eliminated by the creation of artificial intelligence agents and bots and things like that. Probably a lot. But everything I just said will probably create a lot of new jobs. So it's all about us as a human race not drowning in our data and drowning in our technology and giving up the fact that we have rational thought, and these things typically don't. There's something in going way back to Alan Turing, the Turing test, that if I could ask a robot a question and ask a person a question and not know which one was which, the Turing test is basically the thing is behaving in an intelligent way when I can't distinguish which one is the human or not. And when bots first came out, people would just say, "Are you a bot?" And the bot didn't know how to answer that question, and it was pretty easy to fail the Turing test. Well, now they know how to answer that question, and it's not so easy anymore. So what? Let's do some good with this. Let's make some new mistakes and move this forward in a rational, intelligent way, and not just sort of be afraid of it evolving.
The questions of public policy then become prominent in here as well, because of the job issue and because of the fear that's associated with the possible implications of what will happen. So where does public policy now start to intersect this?
Well, I think it's really something that we need to be thinking about. One example of public policy is marginalization, right? So who has access to this technology? Who do we only put the AI technology that works in the emergency room in the hospitals that are in the inner cities because there's a higher volume of people? Somebody could make a rational argument that this needs to be available to everyone. If you make it available to everyone, then you can't take the first step. So I think, as public policy, as people who are setting public policy do what they do, they need to think very seriously about things like asymmetry and marginalization and access to methods and access to technology, just like they do with anything else they do in public policy. The difference is that look how long it took us to even describe what we're talking about here. This is not an easy conversation to start happening. It's not like we're just talking about, changing tires on cars. We're talking about, something that is very, very difficult to explain. It's contingent upon us. Anybody can make this more complicated. It's contingent upon us to make this easier, to let the people who are setting public policy become aware of some of these issues and do what they do well and set policy correctly. And conversely, if that's not happening, to speak up and not to move on and wring our hands about it.
But this is one of the fundamental problems, is the fact that we've been talking now for about 40 minutes, and we're just at the point where we've been able to cover enough of the basics to even have the actual meaningful conversation from a business perspective or a policy or an ethical perspective. How in the world can we simplify this so that non-computer scientists can have a meaningful discussion about it?
I talk a lot about the sort of reflective leadership that goes into leading an organization that is using technology. You can't just hire smart people. You have to teach yourself. You have to, every day, you have to teach something and learn something, right? So the people who are setting public policy, my hope, and this is probably completely naive, is that they're aware that there are technologies that are starting to come about in the news, and maybe they should learn a little bit about them. But to put to your question, from the bottoms up, so to speak, the folks that are very much aware of these technologies and what they do and what the fears and the hopes are for these technologies, we have to make sure that our voice is not only a heard voice, but a voice that makes sense. We can't use a whole bunch of jargon. We can't use a lot of big words. It would be very easy to talk about everything you're talking about in language that's so dense that no one would ever figure out what we're talking about except the people that teach this stuff. And then what? That doesn't help anybody, right? So we have to find ways to bridge these gaps. We can't lead with the technology. If somebody comes to me and says, well, can you use AI to solve this problem? I don't know. Tell me what the questions are. Tell me what the problem is. Don't leap right forward into doing any of this, but at the same time, think about the implications of not, right? What does it mean to your customers? What does it mean to the communities you serve? What does it mean to the marginalized others? All of these are future questions that we really need to be asking.
I mean, certainly what you're saying is right, but what happens in this case, just to give a sense of a flavor of how complex this is, if we talk about these public policy issues, leaving alone the question of what is AI, it creates this huge black box for which data scientists can essentially, and companies can basically do whatever they want without real scrutiny. Or is this is this perspective just wrong?
Well, I don't think the term AI is what causes that, right? So organizations can behave in less than transparent ways in all sorts of ways. And you could ask the same question about collecting customer information. You could ask the same question about using behavior of your customers or your vendors or anybody who comes into your store, so to speak, in quotes, in ways that they don't intend, and what that portends. I think the most important thing here is we shouldn't feel like there's some sort of wall up because we're talking about artificial intelligence. If we need a simple definition, we could say, systems and processes that are intended to behave as intelligent humans would in well understood environments. That's not a perfect definition. It's not a horrible definition. It's sort of an okay definition. And if I had to start a conversation, I would probably start it there. And then I'd probably give some examples. And I'd probably say, like Siri, like a bot, like an autonomous car. Eventually you're going to get into a conversation about the difference between a drone with somebody flying it and a drone without somebody flying it, and what is that. And the FAA is worrying about that right now. They're trying to create regulations that will cover things like that, but we don't start there. Don't start where it's complicated. Start where it's sort of simple and at least reasonably possible to adopt a working definition.
So before we run out of time, there's a couple of other things that we just need to talk about. And we have not really discussed the topic of privacy. And so where does privacy and the data privacy fit into this equation as well, into this landscape?
It's a huge issue. Bots have the ability to observe things and learn things and remember them forever. There's something called an observer effect. When you watch people who know they're being watched, the first thing they do very often is change their behavior. So if you build models and systems to sort of detect behavior based on the past, you know that those systems are detecting the way that behavior is not occurring because the people behaving have changed their behavior, those kinds of things. So security, privacy plays into this. Do I know I'm being watched? If I do I behave differently? Do I have the right to opt in or opt out of being botted to, if you will, to coin a verb, right? There's laws being written as we speak and laws about to be implemented as we speak that talk to general protection of privacy, the right to be forgotten, what the government may and may not do vis-a-vis business. So all over the world, these sorts of laws are being written around data, what data can be transported across borders. Think about this. What happens if you don't transport it across the borders and you make a really stupid decision because you couldn't see all the data? So, the answer to everything isn't as simple as, well, everything is private and everything needs to be contained and nobody gets to see anything. That might be a way of looking at it, but it might be somewhat naive with the amount of data that's being created now. So, this is happening all over the world. We can't ignore it. We're certainly nowhere near done figuring this out.
Yeah, it seems we have barely scratched the surface of it.
Might be a good topic for another CXO talk.
Yeah, actually, I had Michelle Dennedy, who's the chief privacy officer of Cisco, as a guest on CXOTalk, and I don't think we really spoke about AI too much, but you could have endless discussion about this. It's a very complicated topic. But
You could probably get two bots to talk about it too.
that might be a lot of fun. So before we go, two last questions. I'll ask you to answer kind of quickly, just because we're running out of time. And again, these are conversations that you could have. We could spend all day talking about each one of these. But what advice do you have, first off, to business people, to senior executives who may be listening that are saying, "What do I do about all of this stuff?"
So I would say three things. One, be humble. Be realistic. There's no magic button. There's no secret open source code that you're going to pull in that's going to solve all your problems. So be humble about what can and can't be solved with approaches like this. Number two, recognize the fact that doing nothing is actually a choice. You can't just do nothing because you don't know exactly what to do, because that opportunity cost could be very, very, very serious. And number three would be continuous learning of your existing organization, the people in the organization. The skills that got them there are not the skills that are going to take them forward into the future. They're just table stakes. And the people that you're hiring, what skills do you need to fill in those gaps?
Okay, and then finally, what advice do you have on the public policy side? So we've just been talking about the private sector. What about public policy and regulators? What advice do you have for them regarding all of these AI technologies and these deep moral and philosophical implications?
I think we should regulate behaviors and not try to over-regulate specific technologies, because those technologies and specific types of data change so quickly. So we should look at the behaviors. I think we should also look at the unintended impact of sort of over-regulating some of these things, because there's a lot of good that can come from data being used in the right ways and technology being used in the right way. So always consider the balance between the impact of over-regulation and not having enough regulation. And then the last thing I would say is that from a public policy standpoint, maybe we could use a little AI to figure out what's working and what's not working, and not just sort of, speak our way into the truth.
It's funny when I talk with regulators, some of the more enlightened ones. That's one of the things that comes up is, what about the role of AI in
public policy? Yeah,
exactly.
yeah.
Well, we are out of time. We have been talking with Anthony Scriffignano, who is the chief data scientist of Dun Bradstreet. And what an action-packed 45 minutes this has been. You've been watching episode number 204 of CXOTalk. It's going to be on demand for the replay immediately when we're done. And if you are interested in the foundations of AI and the implications, I urge you to watch it. Anthony Scriffignano, thanks again for being with us.
Thank you very much for having me. It was great.
Everybody, thank you. And I also want to give a huge thank you to Livestream, who provides our video infrastructure, and they're flawless. It just works, and we're really grateful for that. Funny thing about live video like we do, live video is an exercise in almost ready to fail because there's so many pieces. And with Livestream, it just always works. And so we really, really appreciate that. Thank you, everybody. We'll have another show next week. Bye-bye.